Hey, everybody. I'd like to welcome our audience today to a quick discussion, or maybe not so quick, that we're having with Nima and Vishnu today on today's topic, which is discussing determinism in the world of AI. I'm David Dennis, and I work in product marketing here at EigenLabs. And Nima and Vishnu, if you guys want to introduce yourself just real quickly.
Yeah. The general manager of AI at EigenCloud.
Great.
Yeah, I'm the CTO of EigenCloud.
Great. So the perfect candidates for this kind of discussion. So if you guys can't explain it, nobody else can. So this term of deterministic AI, it's probably not a term that a lot of people have heard a lot lately. Everybody's heard about the AI bubble and LLMs and everything else is going on, but this topic hasn't come up a lot. So what is it, and what should people think about, and is there anything they can relate to?
Vishnu, do you want to take a stab?
Yeah, sure. So, I always go back to what's happening around us in our systems as well as in nature itself. For those who are familiar with quantum physics, you'll see that many things are non-deterministic. And so, if you look at technology itself, sensors, weather patterns, all of these. Now, if you come closer into distributed systems, network latencies, concurrency control. All of these are, and of course nowadays with LLMs. So those are different sources of non-determinism. So they don't always follow the same execution path at the same time and give the same output. So I think at a high level, I would say determinism in general is something, it's quite powerful in many ways. We'll talk about that in a little bit, I'm hopeful here. And non-determinism also has its uses, essentially. But yeah, at a high level, that's what I say. Nima, what are your thoughts on that?
I mean, it's the fact that we're even having this conversation, I think is kind of interesting because, as long as people have known about software, it's this thing that's reproducible. You're supposed to be able to the code builds, right? Any code that you compile has to have the same kind of behavior as anyone else who compiles it, right? So by nature, it's supposed to be deterministic, right? So then all of a sudden the LLMs come along. You're like, wait, if I give the same prompt to this model and I'm going to get two different results, why is that, right? So the behavior of it kind of is a bit perplexing. So we in the context of why this happens, strictly in this case, right? I think diving into the details of why it's not deterministic and how we can make it deterministic, to just go back to the basics of the things that we are used to, and improving reliability and that sort of stuff. I think it's a good topic to visit.
I mean, you could even say classical computer science has, garbage in, garbage out. There's this idea that, when you put an input in, you should get a known output the other side. You're not used to well, it depends kind of an answer. Yeah. And it sounds like in the realms of LLM AI, we're entering this realm now where kind of to Vishnu's point, you're almost looking at quantum type levels of uncertainty, where you're you could ask the same question and get a different answer each time, and it's hard to know, well, why is that different, and where is it going wrong, right?
Yeah, it's also interesting that these things, because they're based on these neural networks, right, that are supposed to resemble our brains as humans, right? Because people are moody and there's a biology involved and all that sort of good stuff. You're very unlikely to be able to reproduce the exact same scenario of humans at any given point in time, second time, right? So I feel from that perspective, it's pretty interesting. And LLMs are non-deterministic, and then humans are also sort of non-deterministic in that sense.
So is this just a nuisance, or are there scenarios where no, this creates some really big problems?
Yeah, it's a good one. And in fact, David, to your earlier point on garbage in and garbage out, actually what determinism says is, so long as a certain kind of garbage is put in, if the same kind of garbage out comes out, that's fine too.
Right, that's true. Yeah.
But the problem is if the garbage is different, then it's a problem. But right. But having said that, I would say it is useful, right? As I said, if you look at Monte Carlo simulations that you want to do, that model financial markets, for example, weather systems, it could be, any other, many different scenarios. Cryptography itself has some non-determinism built into it. So, for example, to generate nonces, you want to, and factoring of prime, large numbers, basically. That itself is, non-deterministic. So it's kind of like a fundamental property of cryptography itself. Another way to think about it is look at it in game development, right? You actually don't want to have the same kind of behavior. You want some freshness in the experience, right? And so you want maybe people are placing different assets to be gamed at different points. So I think there's a lot of excitement around user experiences themselves. Coming to actual machine learning itself, and not even Gen AI, but even good old machine learning. There are techniques like gradient descent. Sometimes you're stuck in a local optima, and you want to get out of that. In your quest for the local or the global optimum, essentially. So in order to do that, you have to do things like pick a random number and then jump out of where you are, because you're not able to visualize this multidimensional space. So I think that's even in computer science, it's pretty useful. And as I was saying earlier, you also want non-determinism when you have different systems and distributed systems perform at their level best in each scenario, so that the whole is greater than the sum of the parts in terms of performance and things like that. Because if you strictly serialize between different systems, you're going to get a very, very slow system at the end of the day. So yeah, as you can see, and of course in Gen AI itself, having creative outputs, available, outputs, brainstorming kind of outputs, you do want some, non-determinism out there. So, again, I go back to ultimately trying to model nature's own processes,
The one nuance that I want to kind of point out here, though, is there is this difference between randomness and non-determinism, right? Because there are things that you do want to produce via randomness, which you want to replay deterministically, right? That's different from non-determinism.
Yeah.
Right.
Okay. Got it. Because even randomness usually has a set of boundary conditions under which the randomness occurs.
Right. It's like, yeah, I mean, in a system where you can control for determinism, right? You can still, as you're invoking it each time, you can still produce random behavior with it, but that random behavior is deterministically controlled, right? So that's how you can combine it too, basically. And even in the creative pursuits, for example, right? It's like if you want to be able to prove to the world that your specific text to image prompt produces a specific image, right? You can still come up with your own random creative thoughts or whatever, right? You can construct that prompt yourself, right? And then your randomness generates that prompt, which then generates that image, right? But then deterministically, if you replay that, you can prove that was your prompt, that was your creativity that produced that image.
Got it. So a little while ago, I think back in September, Thinking Machines wrote a blog post about this, and we've been working on it for a while now in terms of our own products. How would you kind of compare and contrast what they had to say and what we're doing, and what do you even make of what they said?
Yeah, no, it's actually a very timely question. At the time, our team had been working on it maybe 3 months. Is that right, Nima? More than that. Okay. So and so we were actually very happy to see the validation of the usefulness of determinism. They have a slightly different use case, for determinism than we do. And what's the difference? Of course, Thinking Machines, very well respected, company, doing some really good work, but they're AI focused, right? So which means that even when you're doing reinforcement learning, for example, in order for you to give the right rewards for the model to get better and better, if the rewards are not deterministic, then the model is not going to learn faster. It's not going to converge faster to the most accurate outputs. So I think that's their high level use case. For us, it's a little bit different. Ours is about, as Nima was saying earlier, if you have a certain execution that happened, a certain prompt was given to a Gen AI LLM, and a certain output happened in instance 1. You do the same thing, say, a few minutes later, and a few minutes later, another few minutes later, you do it 1,000 times a day, you get the same outputs, right? So for us, it's like a little more abstracted. For them, it's more a little deeper into the reinforcement learning itself and the rewards given to the model to learn that converge faster. But the ultimate techniques, there were some overlaps, some differences, in terms of how we did it and how they did it. And we were happy to actually get there, earlier than they did. So it's pretty exciting.
Yeah. So, the way I actually think about this is, so I think the phrasing they used was something along the lines of determinism gives you reproducibility, or determinism gives you like re-execution, right? But that's in the name of scientific pursuits, right? You want to be able to peer review each other and validate that like a certain like run was, correct or not, right? And you have a control baseline basically, right? The way that I that I view what sort of we're doing is an extension of that. Not that it's like necessarily different, because re-execution as a result of determinism, right, itself gives you the ability to verify that something happened on the original run, right? David, like if you run like one inference, right, and if I were to deterministically re-execute that run, I can verify what you ran.
So here's like digging into kind of like the next level down. So here's something that it almost seems like a little bit of a catch-22, given that we know at the computational level, once you get like there's actually differences in randomness literally down like at the chip level, right? So you have computational differences in outputs basically due to like quantum effects, right? Then on the other side, you have the possibility going, okay, but I could also have had my data tampered with. And either one of those could mess up determinism, right? So if we think about like what we're building, does it address both of those scenarios, or one more than the other?
Yeah. So I think so maybe, and if I was to like just rephrase that, right, is there are two ways that these things would happen. One is just like within the hardware systems, as I said, like when you have concurrency control, network latencies, going out of order, so you can't reproduce the same thing if you run it again. So that's one reason why you could get that behavior. Another one is data tampering, as in like something maliciously was changed in data, and hence you're getting a different output, right? This prompt like kind of thing that we're talking about. I think like they both ultimately get solved in the same way or similar way, but I think as you said, I think the use cases are different. I think in some cases you may actually want the non-determinism to persist, like for performance and things like that. In the other case, if your property is to make sure that you did A at a certain instant t and you got B, and another instant t prime, you did A prime and you got B prime. Hopefully, if A was equal to A prime, B was equal to B prime, right? So that's really what, no matter how you abstract it and use it in various scenarios, whether it's a data tampering, whether it's like hardware-based reproducibility, whether it's like software, debugging code, obviously you want that. Security audits, you want reproducibility. Like imagine someone trying to like debug code and, they're not able to reproduce it. This happens in multi-threaded systems. It's pretty problematic. So in fact, sometimes you'll actually put in like constraints of serializations so that you can actually figure out like same kinds of traces. So it's actually like it goes, as I said, even beyond like LLMs. Reproducibility is and determinism in software is useful, to converge on things like diagnosing things, proving things that they were run again properly, things like it. But yeah, Nima, I don't know if you have another take on that.
I mean, I don't have another take. I would say that, again, going back to the framework of re-execution gives you verifiability, right? What you're re-executing is the thing that's to be questioned, right? You have this like model and you have a prompt, right? And then you have an output. So you have like these three components. It's the prompt, it's the model, and then you get the output, right? But then when you actually question what the prompt is and this like, notion of context engineering, right? That your data is like fed into that context or into that prompt somehow, right? That's what context engineering is, right? So if the model is acting on the data that you feed into the context and then you get some output as a result of that, if you claim that like some prompt was ran, and then like I basically re-execute that same prompt, that same data, right? If there was any data tampering involved, I would get a different output.
Right.
Through
the obvious.
Because if it wasn't tampered, I would get the same output.
Yeah.
Right. So.
And David, another way to think about this is it's a real world use case, right? Where let's say there's an AI company that has an LLM, and there is a claim made that for a certain prompt, a certain output was obtained, and it's and people dispute it, saying no, at the time when I used it, it actually gave me a different output.
Mm-hmm.
Now this could have real consequences on life decisions, financial decisions, whatever, right? And so for that, in order to say like the original claim of the LLM company is actually valid, you would need determinism. You need all the conditions to be replicated in order to prove or disprove their claim. So it's almost like a proving of a claim that that's kind of another use case, and so that builds more trust and transparency if you have this case.
On that note specifically, actually. So like, a lot of people are thinking about prediction markets, right? And there is this one sort of famous example of Zelensky. Was he wearing a suit at a particular event or not, right? Now, if you had a AI judge sort of like decide whether, because it can interpret images, right? A model, right? If an AI judge was to adjudicate whether he was wearing a suit or not, right? And on one answer, he says, yeah, the model says yes. And another execution of the model says no. And money changes hands and the market resolves in different ways. That's consequential, right? So
we've coined the term of, verifiable AI, or I don't know if we coined the term, but we use this term, right? Is this in some ways our attempt to mitigate basically these kind of problems you guys are talking about?
Yeah, and I think so. Let me just zoom out a little bit, right? So when we say verifiable, there's a difference between that and correctness, right? Because when an LLM executes, there are guardrails that using automated reasoning or what have you, formal logic, you can say that it's not supposed to do a few things, which is adhering to the safety standards of the LLM, right? That's not what we talk about, right? What in our case, when we say verifiable re-executable AI, what we mean is that if did the AI execute the way it said it would?
Yep.
In other words, there's a claim that's being made that it exactly ran this way with these kind of logits and ultimately these kind of prompt outputs and token outputs. If we ran it again, would it do the same thing? So that's a little different from correctness about, is it having a bias? So we don't solve exactly those problems. And the big companies are solving it themselves, like through things like automated reasoning and others. But if that's one distinction, that I would make.
Yeah. So then one way that I've actually heard that be phrased, it's the execution of the AI is verifiable compared to the sensibility of the output that it has, right? Those are two.
Or if it's going to be biased, it's going to be consistently biased.
Exactly. Yeah.
Yeah.
And that kind of like is based on the consistent execution of the model, right?
So where are some, kind of use cases or, kind of real world scenarios where this might come up? You brought up prediction markets, which is one. Are there other kinds of things we're hearing about or people kind of thinking about, or we're thinking about?
I mean, it's an interesting category is games, right? Especially like on-chain games, right? As infra gets better for on-chain games to be built, at the end of the day, when some game has like a prize at the end of the round, right? You might want to know that the AI involved in that game was not modified or was not tampered with by the developer or something, right? So every time, so in this case, both determinism and verifiability of the AI matters to the end user who wants to prove that the AI was executed in the way that was claimed, such that the person who won the prize won it, without any gaming, so to speak, no pun intended.
So this is the fairness of the AI judge.
Yeah.
Got it. Okay.
Yeah.
And also, David, like another way to slightly different angle, but sometimes you can you can still have auditability. So auditability is also another concept here, which gives you trust in AI systems, right? So for example, maybe it's non-deterministic, but if it's run in a private environment that cannot be tampered with, and the results of the output tokens are registered on chain, where you have minimized counterparty risk, then you can. It's like an audit trail, like of that has happened in the past. It's cryptographically protected, and you have no counterparty risk. So that's also another flavor of verifiable AI. So I think like it just depends on like do people want verifiable re-execution, or do they just want overall property of like the AI models not being tampered with, and so it just depends. Both are like verifiable AI. So
yeah,
awesome. So like one of the examples I've kind of heard as a possible danger zone for AI is something like an AI pharmacist. So in that case, the AI, it has to know my medical records, which is already like, this is a privacy concern already. But then for each drug I'm on, there are also contraindications and all of these kinds of things. And those things kind of compile on each other. You hear stories about people who are like, oh, they're on 5 different prescriptions and the compounding effects, can stack on top of each other. For a long time, we've used human expertise to at least try to provide some guidance on this. But the consequence of the AI either having the data tampered with, which is, well, that's my personal medical privacy, or getting the prescription wrong, it's pretty high in terms of the stakes of being like I wouldn't even go so far as to being malicious, but at least being inept, right?
Yeah, no, it's a very important point. Like I think this example that you're giving, it has 2 elements to it, right? One is, does it, based on the contraindications, recommend the right medicine for you ultimately, right? So that's one part. And then the second part is, so that's almost like the semantic, and correctness and safety aspects. The second thing is, when it ran, it was supposed to do that, but it did do something else, right? So there's both of these things, and I think you're absolutely right. I think this can be, it could, ultimately, I think these tools are going to be used for where life and death are involved. I think there's already use cases where these things have caused mental health problems for people. And then and some companies actually say we've solved it, but actually not solved it. I actually think that adding verifiability, we actually enable these companies to grow even faster, because the TAM, the trust, once you have more trust, there's a flywheel there where more customers start using their products. So
right, and I as an end user have to trust the AI pharmacist, right? If I think it's kind of iffy, I'm like, I don't know if I'm going to use your AI pharmacy service. Maybe I'll just right. Yeah, exactly. Hey, well, guys, I think we're getting close to time. Anything you want to add for the audience that you think we didn't touch on that's important to everybody know and understand, especially like where are we going with this in the future?
Well, no, I think at the end of the day, I think trust in AI and AI models and execution is going to be a big thing, because it's going to be a prevalent part of our life.
Yeah,
and so it's going to be everywhere. Right? You see it in autonomous software. You see it in autonomous vehicles. You're going to see it in your homes with humanoids. They better well be like safe and verifiable. Otherwise, it's going to be a challenge, and it's going to be difficult for people to adopt. So this is why you see a lot of the big companies are actually paying attention to all of these. There's also regulation that's coming, and so and even regulation itself, you can have audits around it. So we're actually thinking about some of those kinds of ideas here at EigenLabs to see how we can play a part in providing cryptography and blockchain experience to that field. So
great.
Yeah. I mean, kind of the overarching theme is that these models and agents are just gonna keep getting better, right? Maybe it's not the year of agents, maybe it's a decade of agents, as Karpati said recently, which is probably more accurate. But directionally, right, as these things get a lot better, you're going to come across interfaces or products that are a lot more convenient to use, because these things are more reliable, right? So the more convenient it is, the more you're just going to delegate things to it. You're going to give it more autonomy, things like that, right? People are already kind of delegating their thinking to the likes of ChatGPT, right? So the more delegation happens and the more autonomy happens, you're going to want to have more mechanisms of how do I trust this thing, right? And that's sort of where, so like verifiability and trust are sort of two sides of the same coin, right? It's like trust but verify, sort of, as the saying goes, right? So yes, you can trust it, but how can you also verify it, right? So,
well, especially as it get more convenient, right? If it gets super convenient, it's like, oh, of course it's okay, right?
Yeah.
And we really need to like learn from that and go, oh, that could be exploited either unintentionally or not in terms of our willingness.
I mean, the convenience like sells in any market, basically, right? It's like we're like hardwired biologically to like want to tap into like the most linear systems and most like convenient systems. It's like reduce like calorie expenditure, right? So it's like they're gonna get more convenient. We're gonna have to have more trust rails on top of them, basically.
Well, hey, thanks so much, guys. And this is going to be exciting area, and I know we'll come back and talk about this more in the future. And have a great rest of the day, and thanks so much for spending time on this today.
Thank you, David.
Thanks.
See you.
Yeah. Bye.